So I had a look at through some of my spare backplate options. I'm going to put a D14 backplate onto this chuck to replace the threaded backplate that was fitted originally. So it's going to be fitted for this Smart & Brown 1024 lathe, or 1024, however you like to say it. She's a 1960s lathe, and she's an absolute joy to use. Extremely precise. So I stoned the nose. Didn't really find much. I'm just going to stone the back of the plate, just to make sure there's no dings that will throw off the accuracy of fitting. I can already see a couple. They're very slight, just from storage. This backplate's never been used. It's quite a bit bigger than what I need, but it's what I've got, so this is what we shall use. Anyway, I'm just going to fit all the cam locks and retaining screws. Just a little note on these cam locks. They're marked with an indication line. So you screw this in until, sorry for the shadows, until the line matches, and then spin it around so the retaining screw, which does nothing more than stop these from rotating. They're fairly loose, and that's the way they should stay. So we just put a screw in there to lock it all down. So one of the features I like about this particular lathe is that it has a 5C spindle nose with a drawbar that goes through the headstock, so we can use 5C collets. Which makes for some very accurate turning work abilities. This is a tool room lathe, and it's an extremely well made and precise lathe. I suggest you look it up if you're not familiar with it, because they can be had for quite reasonable money. Anyway, so your 5C collets, you can get up to about 27-28 millimeters, but after that you've got to resort to a chuck, hence going for a GripTru Chuck, so that we can move on. There are other devices we can use. Hang on, I'll actually show you. There's one here. We can use what's called a step chuck. It's a 5C collet, and they initially come as a blank, no machining at all, but all this area here is soft, and we can machine into it steps to whatever diameter we need to work with. And when we do that, when we machine it, we're machining it on the lathe, so everything will be absolutely true. So we can hold things like very thin discs. I don't have anything to show you, but you can imagine that this was a disc that we needed to machine. We could machine this face so that the discs fitted, and then when we pulled the drawbar shut, these would clamp down onto this disc, and everything would be extremely true to the lathe spindle. And that's great. That can take us up to about 5 inch, I believe. or thereabouts. Maybe there are some bigger ones, I'm not too sure. You could even make your own, really, I suppose. Well, we've got the GripTru Chuck, so we fit that on there. As I say, this is a D14. You can get a slightly smaller one, which is a D13. You can get a D16, D18, and I'm sure there are plenty of others. So we fit that on there, onto the spindle nose. Nice and snug. And we're ready to machine it. We want to have the same dimensions as this unit, the old backplate, which we're going to use to guide us. Which ultimately has to fit the back of the chuck. And there, as you can see, this is a little bit bigger than we need, but it's what I've got, so be it. I haven't decided yet. I may leave these on, this extra on, to possibly fit onto a rotary table to make fitting easier. Anyway, I shall get set up and come back to this. Right. So I've worked out my dimensions. We're going to work in millimeters because that's what this lathe dials are. And so we've got 65.5 for the first spigot, 65.45. This measurement and this measurement and this measurement are not too critical. This measurement and this measurement is I'm just going to point at, this is the part that fits tightly into the back of the chuck, and this is the outside diameter of the chuck here. Normally this dimension across here is you need to be very accurate, but in this case we don't, because it's an adjustable chuck, adjustable backplate. So even though it'd be nice to have this nice tight snug fit, it doesn't have to be. So we can be a little bit relaxed on our measurement. So no micrometers in this case. I'm just going to use a pair of Mitutoyo calipers. First of all, I'm going to just clean off the face. I'm just winding my top slide back because I'm going to lock the carriage, so I need a bit of movement in my top slide. So if we lock that down, we'll lock the carriage down there. Touch off. The machine is cast iron, so it will machine very nicely. I'll set 0 just so we know where we are on the top side. Moving the paperwork out of the way. We'll dial in 10mm, see what that does. 6. Just mark that. Let's see what it's given us. .75. Right, we'll work to there and then we'll sort that out afterwards. So back off, come in, and we need to do some bulk removal now. Not sure how much I can take with this lathe, but we'll soon find out. So we're now up to our mark. Remember, at the moment we're just taking off bulk removal. Going to be here a while, so I shall come back in a bit. So we've machined most of the waste off. We're now down to 9.53 and we want 10.54. So we want another millimetre off of there. So I should dial that in and take it off as our last cut. Probably have to do this at high speed. Higher speed. Okay. Set that to 0. So what we've got across there. 75.76, and we want 65, so we want about 10 millimeters to confirm. Okay, I'm not happy with the finish, so I think we're going to take another cut on this. But it's all rather hot, so I'm going to leave it for this evening and come back to it tomorrow. I'll probably put a new insert in, I might have dulled it. And this is why I lock the tops there, the carriage. As you can see, there's an awful lot of cast iron dust, so I shall hoover that off and give it a really good clean at some point before this carriage is unlocked and moved. So I do not want that under the ways. Anyway, that's it for the moment. Right, so it's now the following evening. I've done a quick measurement and we need to take off roughly 9 millimeters off this. So I'm going to start by removing 8. So 2.5 millimeter depth of cut, which is 5 millimeters of diameter. So another 1.5 will bring us up to 8. Just do a quick measure on that. We're looking for 65.45. And we have 66.49. So we need to remove 1 millimeter. So that'll be 0.5 millimeter on our slide to give us 1 millimeter total diameter. $65.57. So 57 minus 45 is 0.12 millimeters oversize. We'll leave it at that for a sec and we'll do a test fit. So it's 0.12 of a millimeter, or just over 1/10 of a millimeter oversize at the moment. So we'll set our vernier to 0 and back out. Grab the piece it needs to fit, and that goes on, and we've got wiggle room, which we do need. We need the wiggle room. Excellent. I'm not sure if we might need a bit more than that. Anyway, we'll come back to that. We'll give it a little lick on a finishing pass. So the next diameter we want to be looking at is this diameter here. So we've determined that we need a 2mm step with a diameter of 101.52. So we'll start by touching off. Actually, I'm not going to do that. I'm going to try and work out roughly visually where I want to be. Okay. I'm just looking for somewhere close for the moment. Right, for the set of verniers, we've measured across here and determined that we need to take off another 4.46 millimeters, which is 2.23 on our cross slide. So just reset that to 0 first, and then we shall go again until we get to 2.23. Should be just slightly over, hopefully. 101.93 and we want 101.52. So 93 minus 52 equals 0.41 of a millimetre. I'm going to back this out as it's so close and just try and see what happens. And that is indeed slightly too tight. I'll just take off a little more on that while we're at it. Got a rough casting on the inside. Lots of chips in that. That's just from the casting. It won't affect our usage at all. So it does look machined, but it's quite rough. So I'll just give it a little bit of a tickle with some paper. And there we are. Perfect. Absolutely no movement whatsoever. And that, let me just zoomed out a little bit. Absolutely no wiggle whatsoever. Very pleased with that. Not sure what I'm going to do with this diameter. I think I might leave it on. It could help with clamping to a rotary table or some such, and I don't really see a problem with leaving it on. If it ever becomes a problem, it's no issue to stick it on here and turn it off. So we're done there. All we need to do now is drill the holes to mount everything. Excellent. And the chuck itself moves on this. This is fixed to that. The chuck itself moves between this and this. Anyway, so we have, let me just, so we have a ton of iron filings to clear up. I mean, there is loads of it. We don't want it in our ways, and that is why I locked the whole carriage so it wouldn't slide up and down, and I just used the top slide and the cross slide and the top slide because they're fairly well protected. So I shall remove all that and clean everything, and then we'll move over to the milling machine to drill the mounting holes.